Between 2012 and 2022, something happened that most people did not notice until it was already finished. Not a single dramatic event, not a headline that changed everything. Something quieter, more incremental, more relentless. A sustained, accelerating, decade-long process by which artificial intelligence went from a niche research interest to a system that could outperform human experts in medicine, law, science, art, and language. While most of the world was thinking about something else entirely, you were there for all of it. You were alive during every year of the most consequential technological transformation in human history. And if you were like most people, you did not see it coming until it was already here. This is the story of that decade, not the headline moments, though there were many. The underlying trajectory, the compounding that happened beneath the surface, the specific, measurable, documented ways in which AI capabilities grew not linearly, but exponentially, doubling and redoubling in ways that made each year's progress more significant than the entire preceding decade combined, and why almost nobody was paying attention. To understand the decade, you need to understand the concept that makes it possible to understand it at all: exponential growth. Human beings are, by evolutionary design, extraordinarily poor at intuitively grasping exponential growth. Our ancestors lived in a linear world. If you planted twice as many seeds, you got roughly twice as much food. If your tribe grew by 10 people, your territory needed to support 10 more mouths. The world operated on roughly proportional relationships, and our intuitions were calibrated accordingly. Exponential growth violates every intuition built for a linear world. A process that doubles repeatedly, every year, every 18 months, every 2 years, starts slowly enough to seem negligible. Then it crosses a threshold where the growth in a single period exceeds all the growth that came before. Then it crosses another, then another. Researcher Ray Kurzweil at Google, who has spent decades studying the exponential growth of computing, describes what he calls the second half of the chessboard, a reference to the old story of the inventor of chess who asked to be paid in rice. 1 grain on the first square, 2 on the second, 4 on the third, doubling each time. The first half of the chessboard seems manageable. Modest amounts, modest growth. The second half becomes incomprehensible. By the last square, the amount of rice required exceeds all the rice ever grown in human history. AI capability in the decade from 2012 to 2022 was firmly in the second half of the chessboard. The decade begins, as we saw in the previous video, with AlexNet in 2012. But the significance of AlexNet was not merely that it won an image recognition competition. It was that it demonstrated a general principle that would drive the entire decade. Scale matters. The more data you train on, the more compute you apply, the more parameters you add to the network, the better the system gets. Not linearly, faster than linearly. Each doubling of scale produced improvements that exceeded what any qualitative architectural change had achieved. This principle, which researchers would later formalize as scaling laws in a landmark 2020 paper by researchers Jared Kaplan, Sam McCandlish, and colleagues at OpenAI, turned out to apply across virtually every domain of AI capability: language understanding, image generation, code writing, scientific reasoning. The same pattern repeated, scale up, and the capabilities emerge. Not because anyone programmed them specifically, because scale reveals patterns that only become visible at scale. In 2016, Google DeepMind's AlphaGo defeated Lee Sedol, an event covered in the previous video. But what happened next is less well known. In the following 2 years, the same team built AlphaFold, AlphaZero, and AlphaStar, systems that achieve superhuman performance in protein folding prediction, chess, shogi, Go, and the real-time strategy game StarCraft II, all using variants of the same underlying approach. The architecture had generalized. The same principles that beat the world's best Go player could, with modification, beat the world's best StarCraft player, predict protein structures, and master every board game ever invented. In 2017, a paper was published that would quietly become one of the most consequential scientific documents of the 21st century. Its title was "Attention is All You Need," written by 8 researchers at Google, Ashish Vaswani, Noam Shazir, Nikki Parmar, Jakob Uskarite, Lion Jones, Aidan Gomez, Lukasz Kaiser, and Ilya Polosukin. The paper introduced a new neural network architecture called the transformer. Unlike previous architectures that process language sequentially, the transformer processed relationships between all words in a text simultaneously, using a mechanism called self-attention to weight the importance of different parts of the input when generating each part of the output. In plain English, the transformer allowed AI systems to understand context in language the way humans do, by considering the full structure of meaning, not just the most recent words. The paper was published in June 2017. By 2018, OpenAI had used the transformer architecture to build GPT-1, the first generative pre-trained transformer, a language model that could generate coherent paragraphs of text. By 2019, GPT-2 was so capable that OpenAI initially refused to release it in full, citing concerns about misuse. By 2020, GPT-3, trained on 175 billion parameters, roughly 1,000 times larger than GPT-1, could write essays, answer questions, summarize documents, translate languages, and write working computer code. The entire progression, from the foundational paper to a system capable of passing professional examinations, took approximately 5 years. Most people did not notice any of this. Not because they were incurious, not because the information was hidden, but because the capabilities being demonstrated existed in domains, research papers, benchmark datasets, academic conferences, that most people have no reason to follow. The world of AI research is, for most people, as invisible as the world of particle physics or deep-sea biology. Interesting in the abstract, inaccessible in practice, and easy to ignore when the concerns of daily life are immediate. And so while AI researchers were watching capabilities double and redouble, while the people closest to these systems were quietly updating their estimates of what would be possible in 5 years, 10 years, the broader public was largely unaware that anything unusual was happening. This is the pattern that researcher Eliezer Yudkowsky at the Machine Intelligence Research Institute has called the unilateral competence problem. The people who understand most clearly what is happening in AI development are, by definition, specialists. The people who make most of the decisions about how society responds to AI development, politicians, business leaders, educators, policymakers, are generalists who must rely on the specialists to translate. And that translation, across the decade from 2012 to 2022, happened too slowly, too incompletely, and with too little urgency. In 2021, OpenAI released DALL-E, a system that could generate photorealistic images from text descriptions. In 2022, Stability AI released Stable Diffusion, making image generation freely available to anyone with a consumer computer. In 2022, GitHub Copilot, powered by OpenAI's Codex model, began writing functional computer code in real time alongside professional software developers, completing entire functions from brief descriptions. In late 2022, OpenAI released ChatGPT, and the world, for the first time, collectively noticed. ChatGPT reached 100 million users in 2 months. It is the fastest adopted consumer technology in human history. Faster than the telephone, faster than television, faster than the internet, faster than smartphones. But here is what most people missed about that moment. ChatGPT was not the beginning of the decade's transformation. It was the end of it. The moment the broader public finally noticed was the moment the technology had already been developing for 10 years. The capabilities that seemed to appear suddenly in late 2022 had been building steadily, measurably, documentably since 2012. The decade-acquired transformation was over. The era of public reckoning had begun. Now here's the part that matters for you specifically. The gap between when AI capabilities were developing and when the broader public became aware of them is not just a historical curiosity. It has direct practical consequences for anyone trying to navigate the current moment. People who were paying attention during the decade, researchers, engineers, entrepreneurs, investors, early adopters, had 10 years to develop mental models, skills, strategies, and positions appropriate to a world shaped by advanced AI. people who only noticed in late 2022 had weeks. The asymmetry in preparation is enormous, and it continues to compound, because the second decade of AI capability growth has already begun. The transformation that most people are only now beginning to process. The capabilities of GPT-4, of image generation, of code writing, of scientific reasoning, represents the output of the first decade. The second decade is already underway, and it will follow the same exponential trajectory. The question is not whether you noticed the first decade in time. You did not if you are like most people, and that is not a moral failing. It is a predictable consequence of how technological change works in a world where the relevant expertise is concentrated in a small number of specialists. The question is what you do with the awareness you now have. Whether you use it to prepare intelligently for the second decade. Whether you develop the understanding of what these systems are, how they work, where they are going, that will allow you to navigate the next 10 years with genuine agency rather than continuous surprise. Researcher Ethan Mollick at the Wharton School of the University of Pennsylvania, one of the most thoughtful observers of AI's impact on knowledge work, has argued that the single most important thing anyone can do right now is to use these systems extensively, not to become dependent on them, but to develop an accurate, calibrated experiential understanding of what they can and cannot do. Not from reading about them, from using them, because the mental model most people currently hold of AI capability is calibrated to a world that no longer exists. Most people's understanding of what AI can do was formed before 2022, before ChatGPT, before GPT-4, before the current generation of image generation, code writing, and scientific reasoning systems. That understanding is systematically underestimating present capability and therefore also systematically underestimating future trajectory. This is the core insight. The decade from 2012 to 2022 was the decade AI was quietly becoming smarter than you. Not smarter than you in every way. Not smarter in judgment, in wisdom, in emotional intelligence, in the capacity for genuine creativity that emerges from lived experience, but smarter in specific, measurable, consequential domains that were previously considered uniquely human. And the decade from 2022 to 2032 will be the decade that determines whether you were paying attention. Organizations like Pinnacle AI Solutions exist for exactly this moment, not to generate alarm, but to help individuals and organizations develop the calibrated, accurate, strategically useful understanding of AI capability that the speed of development has made extraordinarily difficult to maintain independently. Because the most dangerous position in the second decade is not the one occupied by people who fear AI. It is the one occupied by people whose mental model of AI is a decade out of date. Between 2012 and 2022, something happened that most people did not notice until it was already finished. AI learned to see, to hear, to read, to reason, to generate, to code, to discover, to outperform human experts in domain after domain, year after year, while most of the world was thinking about something else entirely. The decade is over. The transformation is not. And the gap between what AI can do and what most people believe AI can do, the gap that opened quietly during that decade, is still closing. Slowly for some, faster for others, and not at all for the people who are still not paying attention.